Problem number 9, same deal. It's quadratic as the other ones. Same deal. We're just going to go ahead and move everything onto one side, and we'll see if we can factor. If we can't, or if we don't think we can do it easily, then we're going to go ahead and use the quadratic formula, which I think might be the case here. Okay, so when I move everything over to one side, I have 3x squared minus an x minus a 15. If I were to factor this, okay, so if I were to factor that, let's see. Well, I would have to have a 3x and an x. But to get 15, well, I'd have to have a 3 and a 5. So let's see here. I'm not quite seeing it, but maybe there's a way. Because if I put a 3, well, if I put a 3 here, that's not going to make a lot of sense because I can factor that out. Okay, so we know that's not going to be the case. So I'd have to put a 5 here, and the 3 would go here, but then I would get 9x and 5x, and there's no way to get down to -1. So I don't think that this one factors just by looking at it. So if it was me, I'd probably just go right to the quadratic equation. And the reason I use a quadratic over completing the square is because I have a leading coefficient here, and I just don't like having to do all the tricks with the leading coefficient to make completing the square nice. I think that they're more confusing than they're worth doing. So we have it equal to 0. We'll go ahead and figure out our A, our B, and our C. So A is 3, B is -1, and C is -15. Okay, now we're just going to go plug those into the quadratic equation. So we've got x is equal to -b. So since it's -b, and again, if you need the formula, I have it in the last problem. Okay, I'll write it out here. So -b plus or minus the square root of b squared minus 4ac all over 2a. So -b is the opposite of b, so this is going to be a +1. B squared is 1 squared, which is just 1, minus 4 times a, which is 3, times c, which is -15. When I look at this, I know that this is going to be positive, so I know that my solutions are going to be real because the discriminant is positive. So I'm not going to end up with like i's in there, I don't think. Doesn't look like it. Okay, so we've got x is equal to 1 plus or minus the square root of 1 plus 4. Well, okay, how am I going to do this? I'm going to take 4 times 15, which I think is 60. And 60 times 3, I think, is 180. I feel like maybe I should check that with a calculator. Just doing it off my head real quick there. Let me grab a calculator. My morning coffee is not close to being done yet, so I don't trust myself. Even with simple things like this. So 4 times 3 times 15. Yeah, it is 180. Okay, good. So there is enough coffee in the tank here. We're good to go. 1 plus or minus the square root of 181 over 6. Okay. So 181, I'm looking for it to see if it's divisible by any perfect squares. Yeah. Well, I know. So what I would check, because I want to try to like reduce this guy if possible. 181, I know it's not divisible by 4. So my perfect squares, remember, are, just write down my perfect squares down here, are 4, 9, 16, 25, 36, 49, so on and so forth. Okay. So I know it's not divisible by 4. The reason I know it's not divisible by 4 is because the last two numbers, 81, aren't divisible by 4. Every time you hit 100, hundreds are always divisible by 4. So anything larger than, any multiple larger than 100 is always going to be divisible by 4. So I really only need to look at the last two. But I know 81 is not divisible by 4. So 4 is out. 9, well, to be divisible by 9, the numbers, the 1, the 8, and the 1, have to add up to something that's divisible by 9. So 1 plus 8 is 9, plus 1 is 10. Now, 10 is not divisible by 9. So 181, notice, and I can just do this on the calculator as well. 181 divided by 9, yeah, it doesn't work. And like I said, 181 divided by 4, that's not going to work out nice either. Okay, so we know if it's not divisible by 4, it can't possibly be divisible by 16, because if it was divisible by 16, it has to be divisible by 4. We know it's not divisible by 25, clearly because it's not. It doesn't end in a 20, like end in a multiple of 25. So it's not like 0, 0 or 25, 50, 75. Okay, so that's out of the question. 36, no, because if it was 36, it would be divisible by 4. 49, I don't think so. Yeah, and I think we don't have to go up any higher, because the square root of, let's see here, what's a nice one near there? Well, the square root of 225 is 15, so I don't have to go up any higher than 15, so I guess I went higher than what I needed to here. So I don't think square root of 181 is divisible by any nice, I'm just going to check a couple here, but by any nice perfect squares. So 64, 81, no. Even if I go up to half of the number, which I don't think I have to, we're still 100. No, it's not divisible by any of them. So we're done. Okay, ugly, yes, but I believe that we're done here. So I think we have two answers. I think one is 1 plus the square root of 181 over 6, and the other one, and I wrote these in reverse order, but it doesn't matter. So I think that those are our two solutions. Now, one thing is, like, when we're working on a practice, when we're working on a practice problem, one thing that I might do is check, like use a website or something to check this value on. So I can't, with the way that my video capture system on this one works, I can't necessarily switch over to show you guys that. But I'm going to check it after this and assume it's right. Otherwise, I'll come back and I'll change the video. But that should be it.